Now let's move on to the topic of remainders. Remainder is 0 if a number is divisible by another number. So if you have a number and you are dividing it with a divisor, if the number is divisible with the divisor, then the remainder for that would come out to be 0. If there is certain remainder that you are getting, that means the number is not completely divisible by another number. So for example, if I look at 4 divided by 2, 4 is completely divisible by 2 to give you a quotient of 2 and no remainder. So if I write 4 divided by 2, I am not dividing it, I am just checking the remainder. When 4 is divided by 2, it will be equal to 0. The quotient that I obtained here, this could be positive, could be negative, or could be 0. So dividend, the number that you are dividing is divisor into quotient plus remainder. So if the remainder turns out to be 0, that means your divisor is exactly dividing the dividend, or I would say your divisor is a factor of dividend. In fact, quotient will also come out to be as a factor of the dividend if the remainder is 0. If there is some remainder that you are getting, then divisor or quotient are not the factors of dividend. When a number m is divided by another number n, so what I am looking in this case is, when m is divided by n, I am looking at the remainder. I am not looking at the quotient part of it, I am looking at the remainder. The remainder would always be between n minus 1 and 0. So that means the remainder could be 0, the remainder could be 1, 2, 3, so on up to n minus 1. So for example, when 7 is divided by 3, when I am dividing it with 3, the remainder that I get is coming out to be 1. When I am dividing 8 with 3, the remainder comes out to be 2. When I divide 9 by 3, the remainder comes out to be 0. When I divide 10 by 3, it will be again 1. 11 would give me a remainder of 2. 12 would give me a remainder of 0. So when I am dividing a number with 3, the remainder could be 0, 1 or 2. The remainder is always 1 less than the number that with which you are dividing. There are certain properties of remainder that we need to understand in order to solve the question of remainders. The first one being, remainders are additive in nature. Additive means that the final remainder can be obtained by breaking the number into parts and adding the individual remainders. So if I just look at it, if I have to look at what is the remainder when 88 is divided by let me call it as 7. Now what can I do is, I can break the number into parts and I can find out the individual remainder, and then I can proceed ahead and solve the question. So what I can do is, I can break it like 70 plus 18 divided by 7. Now I am finding out the remainder. So what I have done is, the numerator 88 has been broken down into 70 plus 18. Why 70? Because when I look at the remainder of 70 with 7, 70 when divided by 7 gives me a remainder of 0, because 7 into 10 is 70, plus the remainder that 18 gives with 7. So this remainder would be 0. If I look at it, 18 when divided by 7 gives a remainder of 4. So the total remainder would be the sum of individual remainders, which will be 4. It is not necessary that I break 88 into something like this. I can break 88 into 80 plus 8. So I'll divide it with 7. Whatever are the individual remainders that I have, I need to find out those remainders and I need to add. So 8 when divided by 7 gives a remainder of 1, and 80 when divided by 7 gives a remainder of 3, because 77 is the closest multiple of 7. So again the final remainder would be 4. The remainder would always be 4 in whichever parts you break. So we break the number in such a way so that we get an easy answer. Let's look at the next property. The next property is, remainders are multiplicative in nature. Similar to what we did in additive, they are multiplicative in nature as well. That means the final remainder could be obtained by breaking the number into parts and multiplying the individual remainders. Now instead of breaking the number into parts with the help of addition, I will break the number into parts with the help of multiplication. So for example, I'll take the same example. This 88, I have to find out the remainder with 7. What I'll do is I can write it as 11 into 8 over 7. So whatsoever is the remainder of 11 with 7, I'll find out the individual remainder of 8 with 7, multiply them to get to my answer. So if I divide 11 with 7, so I will get a remainder of 4, and 8 with 7 gives me a remainder of 1, so I still get the same answer. So I can divide the number by I should say break up the number by either multiplying 2 or 3 numbers or adding 2 or 3 or more numbers and doing the subsequent operations on the remainders. So let's take an example. What is the remainder on the product? This is divided by 12. This is a CAT 2000 question that we had. So what we have to actually do is, instead of actually multiplying the numbers to get to a final number and then dividing it with 12 to find out the remainder, the easy answer is find out the individual remainders, then multiply the remainders to get to your final answer. Now I know when I'm dividing a number with 12, my answer for remainder would be between 0 and 1. So if my answer is coming out to be greater than 12, I will again divide it with 12 to get to the answer. So let's look at it. When 1421 is divided by 12, I just have to check this thing. 1421 is divided by 12, the remainder is 5. So if this is giving me a remainder of 5, the next number 1422 would give me a remainder of 6 and 1423 would give me a remainder of 7. Similarly, 1425 would give me a remainder of 9. So instead of actually multiplying the numbers, I will multiply their remainders, which is 5, 7 and 9. Now when I multiply 5 into 7, 35. So this number is greater than 12. I'll again have to divide with 12 and get to my answer. So if I again divide it with 12, the final answer that I get for remainder is coming out to be 3. So 3 is the final answer that we get. Instead of multiplying the numbers, I have only multiplied the multiplied the remainders and got to my answer. Let's look at a question that we have. What is the remainder when 4 raised to power 2004 is divided by 7? So if something is divided by 7, the remainder could be 1, 0, 1, 2, 3, 4, 5 and 6. The remainder cannot be greater than 6 that I can have. So my answer for this would be in these answer options. Now look at it. What is this 4 raised to power 2004? 4 raised to power 2004 actually means 4 into 4 into 4 into 4 written 2004 time. So instead of actually multiplying the number and finding out the answer, what I'll do is I'll find out the remainders, multiply the remainders and get to my final answer, which is an easy way out. But if I look at this number 4 when divided by 7 would give me a remainder of 4 only, because 4 can be written as 7 into 0 plus 4. Right, my quotient will turn out to be 0 because 4 is a number which is lesser than 7. So what I'll do is I will try to convert 4 into a product of numbers which is higher than 7. So what I'll do is I'll try to make pairs of 2, 3 or 4 such that I get a remainder in the case. So if I look at this, 4 into 4, what is it? 16. 16 when divided by 7 would give me a remainder of 2. I will keep on making the pairs in a way such that I get one remainder. Why? You'll just understand. If I, instead of 2, I look at 3. What is 4 cube? 4 cube is 64. So 64 when divided by 7, I know 7 into 9 is 63 and 1 is the remainder that I get. So I have to do this thing till the time I get one remainder. So 64 is written as 4 cube when divided by 7 would give me a remainder of plus 1. Now if I've got this thing, what I'll do is I'll redo the question and I'll look at the powers and divide the powers. So 4 raised to power 2004 would be written as 4 cube. I've grouped it into pairs and 668. I'll group it into pairs such that if you look at it, this 4 cube is getting repeated 668 times. Now every 4 cube when divided with 7 gives a remainder of 1. When 64, which is 4 cube, when divided by 7 gives a remainder of 1. All the 668 64s that I have would give a remainder of 1. So 1 will be multiplied by applying the multiplicative property of remainders. 1 will be multiplied how many times? 668 times. 1 multiplied even infinite times, my answer would be 1. So the final thing would be the product, which will give me an answer of 1. So the process is, find out the power of the numerator, which gives a remainder of plus 1 with the denominator. Group it into that power and that will give you your answer. It is as simple as that. Let's look at another question. We'll use the same thing. What is the remainder when 25 raised to power 25? Now what is 25 raised to power 25? That means it is 25 which is written how many times? 25 times is divided by 9. I have to find out the remainder when this number is divided by 9. So applying the multiplicative property, I'll find out the individual remainders and I'll multiply the individual remainders instead of finding out the number and multiply the number. So if I look at 129 divided by 9, 25 when divided by 9 gives a remainder of 7. So all of these 25s could be written as 7 into 7 into 7 into 7. How many times? Again 25 times. Why? Each 25 when divided by 9 gives a remainder of 7. Now when I multiply 2 7, the number is coming out to be 49. And when I am dividing a number with 9, the remainder could be either 0, 1, 2, 3, 4, 5, 6, 7 or 8. The remainder cannot be greater than 8 that I have. So when 125 is divided by 9, the remainder is coming out to be 7. So all the 25s can be replaced with 7 and the number would be reduced to 7 raised to power 25 of 7 written 25 times. Now the next step is the most important step. Try to group the remainders in such a way so that when divided by the denominator, the remainder would come out to be 1. So when I look at it, 7, if I combine 7 3 times, 7 into 7 into 7, what is it? 343? 343 when divided by 7, when divided by 9 would give me a remainder of plus 1. So I'll try to group 3s, 3 7s. So if I look at 24, 8 times I'll be able to group them and 1 7 will be left standalone. So all of these 7 cubes could be written as 343 8 times with 7. Now and again apply the multiplicative property of remainders. I'll find out what is the remainder when this number is divided by 7 by applying the multiplicative property. So each 343 when divided with 7 would give me a remainder of 1. When divided by 9 would give me a remainder of 1. So 1 will be multiplied 8 times and you will be left with 7. So the final answer that you will get would be 7. So you'll have 1 into 1 into 1 into 1 8 times and 7. So the final answer would be 7. Let's look at some of the special cases that we need to consider while we are doing questions on remainders. The first one being when both dividend and the divisor have a factor in common. So to find out the remainder in such a situation, I will take out the common factor k. That means divide the numbers with the common factor, but I will not cancel the common factor. The common factor cannot be cancelled. I will take it out. So whatever is the resulting dividend and the resulting divisor is, find out the remainder. So obviously my dividend and divisor would be reduced by a factor of k, which I have taken out. I will divide the resulting dividend with the resulting divisor to find out the remainder. Now the final remainder or the actual remainder that should be there is whatever is the remainder that you have got multiplied with the common factor. So if you look at it, we'll understand it with the help of an example. Now if I'm dividing 8 with 8 is a bigger number, let me declare 18 with 4. Now what I can do is 18 and 4 have 2 in common. So I can take 2 common out. I'll be left with 9 and 2. So whatever is the remainder of 9 divided by 2, which is 1, will be multiplied with the common factor, which is 2, to get to your final answer, which is coming out to be 2. So let's look at an example. What is the remainder when 2 raised to power 96 is divided by 96? Now if I look at it, 96 and 2 raised to power 96 have 2's in common. So if I write down 96, I have 96 is, if you solve it out, it is 32 into 3. So or 96 can be broken down as 2 raised to power 5 into 3. And the numerator that I have is 2 raised to power 96. The denominator that I have is 2 raised to power 5 into 3. This is what I have, and I have to find out the remainders. Now 2 raised to power 5 is common. I'll not cancel it out. This is very, very important thing to be noted in the case of remainders. You can't cancel out the common factors or the common factors. You'll have to only take them out into remainder of. I'm left with 2 to the power 91 divided by 3. So if you find out the remainder here, you can write it as 2 into 2 into 291 times. If you combine 2 2's, which is what? 4. 4 when divided by 3 gives a remainder of 1. So I'll try to break this thing as 2 square, and I'll write 45, because then it will become 90 into 2 divided by 3, and I want the remainder for this. Now if I look at it, this 4 when divided with 3 will give me a remainder of 1. Every number of this kind would give me a remainder of 1. So 1 will be multiplied 45 times, giving me an answer of 1. I'll be left with this. 2 when divided by 3, by applying the multiplicative property, would give a remainder of 2. This remainder would be multiplied with the common factor to give you your final answer that we have. So let's go ahead. 32, I am replacing it. I am writing it with 2 raised to power 91 and 3. So the final remainder when 2 raised to power 91 is divided by 3 is 2, which will be multiplied with 32 to get to your final answer as 2 raised to power 6 or 64. The next thing that we'll understand is the concept of negative remainder. This concept is a very, very important concept, because if you understand this concept, the questions can be solved in a fraction of a second. So let's look at an example. If I have to write 29, it can be written, and I'm dividing it with 15. So it can be written as 15 into 1, which is 15, plus 14, which is what? 29. I can write 29 as 15 into 2 minus 1. That means this remainder plus 14 and this remainder minus 1, I can say these are 1 as the same thing. So when 29 is divided by 15, the remainder is coming out to be plus 14 in the first case and minus 1 in the second case. So the remainder when 29 is divided by 15, either I can say it as plus 14 or I can say it as minus 1. So a negative remainder can always be written as a positive remainder, and a positive remainder can always be written as a negative remainder. Let me take a smaller example and help you understand this. I'm writing down some consecutive numbers. Now if I look at 5 when divided by 3. Now when I'm dividing a number 3 with 3, obviously the remainder would be 0. When I'm dividing 4 with 3, the remainder would be 3. When I'm dividing 5 with 3, the remainder would be 2. This would give me a remainder of again 0, 1, 2, 0, 1, 2, so on. Now what does this mean? Look at the two multiples of 3 that you have, 3 and 6. This number is 2 more from the previous multiple of 3 and 1 less than the next multiple of 3. So what does it mean? I have a surplus of 14. That means from the previous multiple of 15, there is a surplus of 14. Surplus of 14 is from the previous multiple, and from the next multiple it will be regarded as a deficit. So from the next multiple, that means to reach to the next multiple, I need one more. To get to a multiple of 15, I need to have 15 jumps. I already have 14. So how many more I need? I need one more to move to a next multiple of 15. So plus 4 and minus 1 is the same thing here. When I'm dividing it with 3, plus 2 and minus 1 means 1 is the same thing. Plus 2 means from the last multiple I have 2 surplus, and to reach to a next multiple I need one more. So this 5 can be written as 3 into 1 plus 2 or 3 into 2 minus 1. From the first multiple I have surplus of 2. For the next multiple I have a deficit of 1. So negative remainders means a deficit. Now this positive can always be written into a negative thing. Now if you look at it, whatever number you are dividing with, if you are dividing m with n, the remainder we have already talked about could be between 0, 1, 2, so on up to n minus 1. So if you look at it, these remainders will the absolute value of positive and negative remainder add up to give you the number itself. So I'm talking only about the absolute value. It will be 15. 2 plus 1 is equal to 3. So if I'm dividing a number with 14, I'm just supposing, if I'm getting a plus 8 remainder, that means in a negative sense, it would be what? Minus 6. Because 8 and 6 would add up to give you a 14 value. The absolute value of positive and negative remainders add up to give you the divisor itself. So let's look at the theorems that we have to help us in solving the questions on number system. So remainder theorems. The first theorem that we'll start with is Euler's theorem. However, the questions could be done without the help of these theorems as well. But if you know the theorems, you can solve the question a little quickly. If m and n are two numbers co-prime to each other such that HCF of m and n is equal to 1. Now what does that mean? You are dividing m with n and you have to find out the remainder. M raised to power something. M raised to power, let me call x. You have to find out the remainder. Now the first step should be these numbers m and n should be co-prime. Co-prime means if there is a common factor, then take out the common factor. The method that we have already learned, if there is something which is common in dividend and divisor, you would always take out. So these rules, whatever theorems we are going to study, these theorems can only be applied once we take the common factor out or once we simplify the question. So the first thing that we have to look at is m and n should have a HCF of 1. Now the next step is do the prime factorization of n. So prime factorization means again ABC raised to PQR. The similar thing that we have done while we were doing the question on remainders. Once you do prime factorization, find out the Euler coefficient. Now the value of Euler coefficient would be given as this. If you look at this, this is the value of Euler coefficient that we have. Phi n or the Euler coefficient n is given by n into 1 minus 1 by a, 1 minus 1 by b and 1 minus 1 by c. This is also known as Euler function or Euler totient function. Now what are ABC? ABC are the prime factors that we have obtained already. So these are the prime factors that we have obtained. Now once you find out this value of Euler function, m raised to the power Euler function when divided by n would always give a remainder of 1. That is what the Euler's theorem is. Now if I have to just take an example for Euler theorems, let's look at the question that we have. So if I am, let's say, dividing 31 with 6, I know 31 when divided by 6 gives me a remainder of 1. So that is very simple thing. So let me take 32 raised to power 32 raised to power 500, right? This is the question that we have. If I'm applying Euler theorem, every question can be done without Euler theorems as well. So, but we are doing this with the help of the Euler theorem. So, if I look at 6, 6 is 2 into 3. What is be the value of Euler function? It will be 6, 1 minus 1 by 2 and 1 minus 1 by 3. So, this will give me 6 into 1 by 2 into 2 by 3. So, if I just solve it out, it gives me an answer of 2. So, that means 32 square when divided with 6 would always give a remainder of plus 1. So, if I have 32 raised to power something, I can always write it like this. 250 when divided by 6 would give a remainder of. Every 32 square gives a remainder of what? 1. 1 raised to power 250 would still give me a remainder of 1. So, very important thing that you have to first look at is, now if you look here, is the HCF of m and n 1? No. So, the way that we have applied Euler function is an incorrect way. The first thing that we have to do is divide 32 with 6. So, if I look at it, 6 is what? 2 into 3. I will take 1 2 common and I will cancel that thing out. I will not cancel that thing out, but I will basically move ahead and solve that thing out. So, if you which is what? 32. 32 is 2 raised to power 5 raised to power 500. What is it? 2 raised to power 2500 divided by 2 into 3. So, 1 2 will get cancelled out. This is, no, I'll not say cancel out, I'll say common. 2 raised to power 2499 divided by 3. Now, if I look at it, every 2 when divided by 3 gives a remainder of plus 2, or now I'm going to write it as minus 1. Minus 1 would be repeated 2499 times. When divided by 3, it will give me a remainder of minus 1. Minus 1 remainder with 3 can be converted into a plus remainder, which means it can be written as plus 2. So, what is the remainder that I have got now? Plus 2. My final remainder would be this 2 into this 2, which is giving me an answer of 4, which is the correct answer. So, if I do not cancel the thing, do not take the things common, I will get a wrong answer. This is not the correct answer that I have. This is the wrong answer that I will get. I hope the question is clear now, or I hope you know how to apply Euler theorem now. Let's look at the second theorem that we have. The second theorem is, if n in the above Euler theorem is a prime number. So, I was dividing m with n. What the question is saying, if n is a prime number. If n turns out to be a prime number, its prime factorization would not be possible. So, for example, if I am dividing a number with 7, 7 can only be written as 7 raised to power 1. So, the value of Euler function would be a little different. It will be n into 1 minus 1 by n. Reason being, it cannot be prime factorized. So, it will be 6 into 6 by 7, giving me a value of 6. So, the theorem that I will have is m raised to power phi n. Now, the value of phi n in this case, in case n is a prime number, would always be fixed, and that will be equal to n minus 1. If we are dividing it with 7, this we are getting it as 6. M raised to power n minus 1 when divided by n would always give me a remainder of 1. This is what the theorem states. The only thing that you need to consider here again is m and n, the numbers that you have, m and n should be co-prime to each other. That is very obvious in this case, because if n is prime, m will not be a multiple of that prime. If it's a multiple, the remainder would always turn out to be 0 that we'll have. Let's move ahead and look at Fermat's theorem. Fermat says, if p is a prime number and n is a number which is co-prime to p. So, what does that mean? N and p have nothing in common to share with. They have an HCF of 1. If p is a prime number and n is co-prime to p, then n raised to power p minus n is divisible by p. That means n raised to power p minus n when divided with p would give me a remainder of 0. So let's take the values. Let me fix p as 7 and the value of n you can take anything as 12. So what is it? 12 raised to power 7 minus 12 over 7 would give me a remainder of 0. This is the rule that you can apply always. Thus the only thing that you have to take care is that p is a prime number that we have, and n and p should have an HCF of 1, or should be the numbers which are co-prime to each other. So what is the question that we have? What is the remainder when n raised to power 7 minus n is divided by 7? Let me just do one thing. Let me just erase the thing that I have written on the slide. So let me just give me 1 second. Now, let's look at the question that we have. What is the remainder when n raised to power 7 minus n is divided by 14? This is the question that we have. So if I look here, since 7 is prime, so n raised to power 7 minus n will be divisible by 7. Now this is the thing that I am going to apply here. N raised to power 7 minus n over 7 gives me a remainder of 0. Now what does that mean? N raised to power 7 minus n is a multiple of 7, is some multiple of 7 that I have, is divisible by 7. Now when I am doing it with 14, I am trying to split 14 as 7 into 2. If a number is divisible by 7 and by 2, it will be divisible by 14. So this number is divisible by 7, that I have already understood. Now if I look at n raised to power 7 minus n, I can take n common, it will be n raised to power 6 minus 1. This is what I can apply the formula a square minus b square, and I will get the expansion as n into n minus 1 into n plus 1 into n square plus n square plus 1. Now if I look at it, this is a product of 3 consecutive numbers. Out of 3 consecutive numbers, at least one would be even. So the product will turn out to be an even thing. So that means this number is even number and divisible by 7. So that means it is divisible by 14. If a number is divisible by 14, the remainder would turn out to be 0. Let's look at the fourth theorem. The fourth one is Wilson's theorem. Wilson's theorem says if p is a prime number, then the remainder of p minus 1 factorial with p would come out to be minus 1. So that means if I do plus 1, it will give me 0. I'll just explain it again. In other words, I'll say p minus 1 factorial plus 1 is divisible by p if p is a prime number. It also means that the remainder when p minus 1 factorial is divided by p is minus 1. Minus 1 means p minus 1 when p is prime number that I have. So if I just look at the question, what is the remainder when 16 factorial is divided by 17? Now what is 17? 17 is a prime number that we have. If I just apply the theorem, p minus 1 factorial when divided with p would give me a remainder of p minus 1. This is what we can remember the theorem. If this is a little difficult for you to understand, just remember this. That means p minus 1 factorial when divided by p gives a remainder of minus 1. If I add a remainder of plus 1, minus 1 and plus 1 will get cancelled out to give me a total remainder of 0. So what is this? This is p minus 1 factorial, which is 16 factorial, divided by what? 17. The remainder would be p minus 1. It will be coming out to be 16. If you want to understand it, you will understand it that every term except 16 is divisible by 17 in the above expression. What is the expression? 16 factorial, I have written it as 16 factorial plus 1 minus 1. So I have just combined this thing, 16 factorial plus 1 plus 16 minus 17. Now this 16 factorial would be a number which is a multiple of 16 plus 1, that means it will be a next multiple, next number's multiple, which will be 17. This is already divisible by 17, so this will be the only thing that I will be left with. So the only thing that you can remember is p minus 1 factorial when divided by p would give a remainder of p minus 1. The other thing is p minus 2 factorial when divided by p would give me a remainder of plus 1. Here the remainder is minus 1, here the remainder is plus 1. So if the question would have been what is the answer when 15 factorial is divided by 7, the remainder in that case would be 1. 16 factorial divided by 7, the remainder in that case would be 16. Let's look at another theorem that we have, which is very important theorem, Chinese remainder theorem that we have. This is a very important thing that we need to understand. Now I am dividing m with n to find out the remainder. Now this n number can be broken down into a into b, where a and b are co-prime to each other. That means HCF of a and b is coming out to be 1, that I should write here co-prime, whereas HCF of a and b is coming out to be 1. And m is a number m. So what I'll do is I'll try to divide m with a separately, find out the remainder. I'll try to divide m with b separately, find out the remainder. Now the final remainder that I'll get when m is divided by a into b. Now look at here, this is not the multiplicative property of remainders. I'm not breaking the number which is there in the numerator into parts and multiplying the remainders. I am breaking the divisor or the thing that I have in the denominator into two parts. So the final remainder would be given by, I'll look at this a, multiply it with r2, look at this b, multiply it with r1. So I'll cross multiply the things and I'll get my answer as a r2 x plus b r1 y. What is this x and y? X and y has to be found out such that ax plus by is equal to 1. This a and b I need to figure out in the question. So if let's say if I have to look at the question, let's just form a question that we have. If we are dividing a number with 35, any number, right? So instead of actually dividing the number with 35, I can break 35 into 7 into 5. Now what I do is, I find out the remainder of n with 7. Let me call this as r1. I find out the remainder of n with 5. Let me call this as r2. Then my final answer would be 7 r2x plus 5 r1y. So if you want to put the value of n, any value that you want to put here, that you like, let's take the thing to be something like 71. If I take n is 71, so 71 when divided by 7 gives a remainder of 1. 71 when divided by 5 also gives a remainder of 1. So I'll substitute the values of r2 and r1. So my answer will be 7x plus 5y. How to find x and y? Such that ax plus by is equal to 1. Now I have to find integer answers for x and y such that the equation is getting satisfied. Now if I just look at it, I can write 7x is equal to 1 minus 5y, or x is equal to 1 minus 5y by 7. So I'll keep on putting some values of y, integer values of y, for which I will get integer answers. Now for example, if I put y is equal to minus 4, 5 into 4 20, it will be plus 1 21, x will come out to give you a value of 3. So I'll put this 7 into 3 plus 5 into minus 4, 21 minus 20, my final answer is 1 that I have in this case. When the dividend is in the form of a raised to power n plus b raised to power n or a raised to power n minus b raised to power n, then a raised to power, there are certain set of rules that I'll remember. The first one being a raised to power n plus b raised to power n is divisible by a plus b when n is odd. So when n is odd, it is divisible by a plus b. A raised to power n minus b raised to power n is divisible by a plus b when n is even. So these are the set of rules that I'll have to take into consideration while solving the questions. And a raised to power n minus b raised to power n is divisible by a minus b always. So it is always divisible. So when you have a raised to power n minus b raised to power n, you will have two results, a minus b and a plus b. This will be always, and this will be only when it is even. Whereas when you have a raised to power n plus b raised to power n, it will be divisible by a plus b when n turns out to be odd. So these are the set of rules that we need to look. Let's look at the extensions for the formula. If instead of 2 I have 3 or more, a raised to power n plus b raised to power n plus c raised to power n, so on. If n is odd, the same rule that I'll apply, it will be divisible by a plus b plus c plus d. So it will be divisible by a plus b plus c if n is odd. And ABC that you have, these ABC are in AP. AP means arithmetic progressions. This formula can be extended to any number of terms provided A, B, C, D, E, F, etc. are in arithmetic progression and the power n that you have is odd. So this is the result that we can apply whenever we have a question of this type, or whenever the dividend is in the form of a raised to power n plus b raised to power n or a raised to power n minus b raised to power n. Let's look at an example for this. What is the remainder when 3 raised to power 444 and 4 raised to power 333 is divided by 5? Now look at it. The form is a raised to power n plus b raised to power n. This n has to be same. So what I'll do is I'll look at 444 and I'll look at 333. If I just look at them, 111 is a common factor that I have. So what I'll do is I'll try to convert it into the form of a raised to power n plus b raised to power n. So 3 raised to power 444 will be written as 4 inside 111, 3 inside and 111. So this is the value of a that I have and this is the value of b that I have. So the value of a comes out to be 81, the value of b comes out to be 4 cube, which is 64. So it's a question which is of this type, 81 raised to power 111 plus 64 raised to power 111. Now if you look at it, it is of the form a raised to power n plus b raised to power n, and n here is odd. So it is divisible by a plus b. So if I look at it, it is divisible by 81 plus 64, which is 145. If a number is divisible by 145, it will be divisible by its factors as well. So that means if a number is divisible by 145, it will be certainly divisible by 5 and the remainder would come out to be 0. Let's look at another type of things that we have in remainders. When the function is there, a plus bx plus cx square plus d, that means it's a polynomial that you have in the numerator. And what are you dividing with? You are dividing with x minus a. What you do is, whenever you have questions of this type, what you do is when you are dividing with x minus a, in the question you put x is equal to a. You put x is equal to a. So you find out the value at fa. That means fa, you find out the value. If the value of fa is turning out to be 0, that means x minus a is a factor of fx. If the value is not 0, whatever is the value of fa that you are getting, that is the answer for your remainder. That will be the remainder that you will get when you are dividing it with x minus a. Let's look at the question. What is the remainder when 3x cube plus 2x square minus 5x plus 3 is divided by x minus 1? So I'm dividing it with x minus 1. I will put x is equal to plus 1. So it is x minus a you are dividing, you put x is equal to plus a. So if you put x is equal to 1 in the question that you have, you put the value of it 3 into 1 cube plus 2 into 1 square, 3 1. So if you look at it and if you solve the values, it is coming out to be 3. So that means x minus 1 is not a factor of the given equation that I have. So if it is not the factor of the given equation here, it gives a remainder of 3. Let's look at another question. This is the question and it is saying is divisible by. Divisible means this is a factor. This is a factor. A factor gives a remainder of 0. That means when I fill the value of the function at 1, I'll just fill the value at 1. The answer should be 0. So if I just start with filling f1 should be equal to 0. 1 minus 3 plus 4 plus c is equal to 0. The value of c that you end up with is minus 2. There's some generalization that we need to keep in mind whenever you are doing your question on remainders. A plus 1 n over a will always give a remainder of 1. So that means if you have a number like 7 divided by 6 raised to power n, this 7 is can be written as 6 plus 1. 1 divided by 6 is a remainder of 1. Even when done n times would always give a remainder of 1. A raised to power n over a plus 1. So what is it? It's something like what is the remainder when you want to say 7 is divided with 8. 7 raised to power 1 is divided with 8. Now when n is even, the remainder is 1. When n is odd, the remainder is a itself. So if you want to keep this 7 divided by 8 odd, the answer is 7. If you keep it even, 7 square 7 square 49. 49 when divided by 8 would give a remainder of what? Plus 1. So if you remember these generalizations, you will be able to do some questions really quickly. If n is divisible by q, then all the multiples of n will also be divisible by q. That means remainder would be 0 in all such cases. Now what do I mean to say? If a number n is divisible by q, divisible means it leaves a remainder of 0. That means n is k times q. Any multiple of n, that means x into n, would also be divisible by q. Would also be divisible by k. That means the remainder would be 0 in all the cases, that we have. If n is divisible by q, then all factors of q will also divide n. Remainder would be 0. That means if a number is divisible by, let me call it as 100, then this number would also be divisible by 2, would also be divisible by 5, would also be divisible by 10, by 25, by 50 and by 100. So that means if a number is divisible by a certain number q, all factors of q would also divide that given number. That means the remainder would be 0 in all of these cases. Something that we have done just back, that the number was divisible by 145. We said if a number is divisible by 145, it is certainly divisible by 5. Let's look at another case, that is when a digit repeats itself n times. So any digit which is written 3 times side by side would be divisible by 3 and 37. For example, if I write a digit 3 times, same digit 3 times side by side, it will always be divisible by 3 and 37. Any digit written 6 times or 9 times or 3n times will always be divisible by 3 and 37. Very important. So if I am writing a digit thrice, it will be always divisible by 3 that I have. And if I am writing it 6 times or 9 times, that means multiples of 3. It will be divisible by 3 and 37. 7. Any number of the format ABC, ABC. Now what is it? ABC are distinct, but it is repetitive. So if I am talking about 1, 2, 3, 1, 2, 3 of this form, it will be divisible by 7, 11 and 13. Any number of the format ABC, ABC is divisible by, here it is the same digit which is repeating. Same digit repeating. Now in the second case, it is the same pattern which is repeating. It is not the same digit, it is the same unit which is repeating. Same, I should say same pattern repetition or same unit. It's a 3 digit unit which is repeating itself. Here it is divisible by 7, 11 and 13. Let's look at the next thing that we have. If P is a prime number greater than 5, then any digit written n minus 1 times will be divisible by P, where n is the recurring decimal of P. Recurring decimal is the number of times after which the digits gets repeated for decimal. So if I look at it, 8, 8, 8, 8, 8, 8. 8 is written how many times? 6 times. Now when I am writing 8 6 times, this number that I have is divisible by 7. If I look at this 2 that I have, 2 has been written 12 times. This 12 times written 2 would be divisible by 13. Now look at the case again. If a prime number P greater than 5, any digit written n minus 1 times will be divisible by P, where n is the recurring decimal of P. Now let me call this thing. If you have taken the prime number as 13, 13 is a prime number. What is the number which is just before 13? It is 12. If you write a digit, any digit 12 times, any digit 12 times, it will be always divisible by 13. 7. What is the recurring decimal of 7? 6. So if you write any digit 6 times, it will always be divisible by 7. Let's look at another prime number like 11. What is the recurring decimal of 11? It is 10. So if you write any digit 10 times, this would always be divisible by 11 that I have. That means remainder would come out to be 0. Let's move with the next topic. The next thing that we will do is the highest power dividing a factorial. Highest power of the given number is what we have to find that divides the factorial of another number. Divides the factorial of another number means it completely divides. That means the remainder should be 0. That means the factorial should actually be a multiple for the given number. But first let's look at what does a factorial mean. Factorial of any number means multiplying all the consecutive natural numbers starting from n to the number itself. So if I have to find 8 factorial, I'll start from 1, I'll keep on multiplying all the consecutive natural numbers till that number. The things that I need to look at is 0 factorial, the value is 1. 1 factorial, the value is also 1. And n factorial can be written as n into n minus 1 factorial. This is a very important way in which you can write down the things. For example, if I have to write 8 factorial, I can combine these. What is this? This is 7 factorial into 8. So n factorial is n into n minus 1 factorial. I can also write it as n minus 1 into n minus 2 factorial. That means I have combined till 6. I have written it as 6 factorial. Okay, this will be 7, this will be 8 that you will have. So the question that we are going to do here is to understand highest power is What is the highest power of 5 in 8 factorial? I've already written 8 factorial as 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. Now if I combine all the 5s that I have only one 5. So if I divide 8 factorial with 5, the remainder would be 0. So the highest power of 5, which is dividing 8 factorial, comes out to be 1. So highest power of 5 that comes out to be is coming out to be 1. If I look at highest power of 2, I will look at this 2. This is again 2 square. This is again 2 cube. This also has a 2. So I'll combine all the 2's that I have. I'll combine all the 3's that I have, and I'll write it in the prime factorization form. So the highest power of 2 dividing 8 factorial is 7. The highest power of 3 dividing 8 factorial is 2. The highest power of 7 is 1. The highest power of 5 is again 1. This is how we solve the question related to highest power dividing a given factorial. So let's look at another question that we have. What is the highest power of 5 in 80 factorial? So the question that we are given is 80 factorial. Now, it is very difficult for me to write 80 factorial as 1 into 2 into 3 into 4 into so on up to 80. Then combine all the 5s. So I have an easier method. The method is a 4-step method. The first step being divide 80 with 5 for the quotient. Omit remainders in any. Now here I do not have to look at any of the remainders. So 80 when divided by 5 gives a quotient for 16. Again divide the quotient that I have obtained with 5 for again the quotient. So 16 divided by 5 gives a quotient of 3. Remainder of 1 I have omitted it out. Again 3 divided with 5. Keep on doing so till the time you get 0, and the greatest integer function here represents the quotient, not the remainder. So the quotient would be 0. So the highest power of 5 in 80 factorial will be the sum of all the 3 quotients that you have obtained, 16 plus 3 plus 0, which gives you an answer of 19. This is the steps that you follow in order to find out the highest power of a given number in a factorial. Let's look at another question. The question is, what is the highest power of 15 in 80 factorial? Now 15 is not a prime number. I'll break 15 as 5 into 3. So I'll split it into 2 co-prime factors, 5 and 3. Find out the highest power of 5 in 80 factorial, which I've already done in the previous case, which was coming out to be 19. Find out the power of 3 in 80 factorial. So I'll do it with 80 with 3. 80 divided by 3 gives a quotient of 26. 26 when divided by 3 gives a quotient of 8. 8 3s are 24 plus 2. So 8 when divided by 3 gives a quotient of 2. 2 when divided by 3 0, and so on. So highest power of 3 would be 26 plus 8 plus 2, which gives you 36. Highest power of 5, which we have already calculated, is 19. So I have 19 5s and I have 36 3s. 15 will be formed by a combination of 5 and 3. So the highest power of 15 in 80 factorial will be the minimum of the two values, which is 19 and 36, which gives me an answer of 19. I hope you are clear with the question. Yeah, if you have to calculate the number of zeros in the end, this is basically the application of just what we have studied. Highest power of a factorial application is finding out the zeros in the end. So number of 0 basically refers to the highest power of 10, which can divide the given factorial. 10 can be split into 2 co-prime factors, 2 and 5, because 10 is not a prime. So we'll find out the highest power of 2, we'll find out the highest power of 5. Whatever is the minimum out of 2 would be my answer. Generally, power of 5 is sufficient for the answer. I'm talking about generally, power of 5 would be sufficient for the answer, because power of 5 would always come out to be lesser than the power of 2. So let's look at the question. What are the number of zeros in 75 factorial? I look at the highest power of 5 and 3. So 75 divided by 5 give me 15. 15 divided by 5 give me 3. 3 divided by 5 would give me 0. So the number of 5s are 15 plus 3, which is 18. That will be my answer. I will not look at 2. If you are looking at 2, basically you are wasting your time, because if you look at 2 only, 75 only divided with 2, you will get an answer which is much more than 18 itself in the first step. So omit these steps, redundant things, only look at the 5 value to get your answer for number of zeros in the end. Now let's look at some of the examples related to number system. Let S be the set of prime numbers greater than or equal to 2 and less than 100. Now, by the way, how many prime numbers are there which are less than 100? You need to count them. So 2, 3, 5, 7, 11 and so on. So there are 25 prime numbers which are below 100, out of which 15 are between 2 and 50, and 50 to 100 there are 10 prime numbers. So the question is, let S be the set of prime numbers greater than or equal to 2 and less than 100. Multiply all the elements of S. How many consecutive zeros will be there at the end? So I'm multiplying 2, 3, 5, 7, 11, 13, 17, 19, so on. What is the largest prime number that you have? 97. Now if you multiply them, how will you get a 0 with 5 and 2? How many 2's are there? Only 1, 2. Because all the other prime numbers are odd. How many 5's are there? 1. None of the other prime number will be a multiple of 5. That cannot happen, because if it's a multiple of 5, it will not be a prime number. So it will have only 1 0. This will be the answer that I have. It will have only 1 0 in the end. Let's look at another question. There are 7 prime numbers such that P1 is less than P2 less than P3 less than and so on. And when you multiply them, it ends with a 0. So that means what? 0 means there should be 1, 2 and 1, 5. What is the value of P1? What can be the value of P1? 2. Very simple questions.